Before there were oceans, before clouds drifted above mountains, before life ever opened its eyes, Earth may have been a world that should have remained dry forever. Yet today it is blue, wrapped in seas so vast they seem eternal. The mystery is not only how water shaped this planet. The deeper question is far more disturbing. How did water get here at all? Was it born from Earth itself, delivered by cosmic violence, or forged in events that began long before our world existed? The truth is stranger, older, and far bigger than anything our ancestors could have imagined. Imagine the Earth 4.5 billion years ago. No forests, no rivers, no rain striking leaves. Only a wounded sphere of rock glowing under a sky choked with ash and fire. Continents had not yet settled. The surface was a battlefield of magma oceans, erupting fissures, and impacts so violent they could boil entire regions into vapor. This was not a blue planet. It was a furnace. And by every simple expectation, a world born in such heat should have lost its water before it ever had the chance to keep it. That is where the mystery begins. Because somehow, against astonishing odds, Earth became the only known world in the universe where water did not merely arrive. It endured. It pooled into oceans, rose into clouds, carved valleys, fed cells, and eventually entered blood. Every living thing on this planet carries that ancient inheritance. The water in your body may be older than the sun's warmth on Earth, older than the continents, older even than the world itself. It is not just part of our story. It may be one of the deepest stories in the cosmos. For generations, scientists believed Earth's water must have come from outside, delivered after the planet cooled. The logic seemed obvious. Forming so close to the young sun, the newborn Earth should have been too hot for water ice to survive. Any early moisture would have been blasted away by radiation, stripped by impacts, or lost to space. In that view, our oceans were cosmic cargo, carried here by comets or water-rich asteroids crashing into the infant planet during an age of celestial bombardment. At first, that idea felt almost poetic. Ice wandering through the darkness. Comets blazing across the early solar system like frozen messengers. Asteroids, shattered remnants of planet formation, slamming into Earth with enough force to devastate continents, but perhaps enough generosity to leave behind oceans. It was a vision both violent and beautiful. Water as a gift from space, life as an accident of impact, our seas as survivors of chaos. But the deeper researchers looked, the stranger the story became. Comets, once blamed or praised as the main carriers of Earth's water, did not all match the chemical fingerprint of our oceans. Some contained a different balance of hydrogen, a subtle isotopic signature that suggested they were not perfect parents to the water filling our seas today. Asteroids seemed more promising. Certain ancient meteorites held minerals rich in water and chemistry closer to Earth's own. Yet even that answer was incomplete. It explained delivery. It did not explain destiny, because having water is one thing. Keeping it is another. Early Earth was under constant assault. Giant impacts could vaporize oceans into steam. A restless mantle could swallow water deep underground. A young sun, more violent than the one we know now, flooded nearby worlds with brutal radiation. Mars lost most of its surface water. Venus became an oven. By all appearances, Earth should have joined them, and yet it did not. Somewhere between fire and annihilation, something extraordinary happened. Water remained. It cycled through rock, sky, and sea. It became part of the planet's engine. And that raises the question that changes everything. If Earth should have been born dry and should have been stripped bare even after receiving water, then what hidden process turned this impossible world into an ocean planet? Was our water delivered from space, forged inside Earth, or protected by conditions so precise that without them, no ocean, no biology, and no human history would ever have existed at all anywhere here? To answer that question, scientists had to look far beyond the shoreline and far beneath the crust. The search for Earth's water became a detective story, written in atoms, trapped inside meteorites, volcanic glass, and crystals, forged under impossible pressure. And what they found began to overturn the old, simple picture. Water may not have arrived in a single dramatic delivery. It may have entered Earth through multiple doors, at multiple times, in forms almost invisible to the naked eye. The first clue came from the chemistry of hydrogen. Water is H2O, but not all hydrogen atoms are identical. Some carry an extra neutron, creating a heavier form called deuterium. That tiny difference acts like a fingerprint. By comparing the ratio of deuterium to normal hydrogen in Earth's oceans, with the same ratio in comets, meteorites, and planetary materials, researchers could ask a profound question. Which ancient source looks most like the water we drink today? The answer was unsettling. Many comets, once imagined as the great donors of Earth's oceans, carried too much deuterium. Their water was similar, but not similar enough. That did not rule them out completely. Some may still have contributed, but they no longer looked like the main source. Attention shifted toward carbonaceous asteroids, primitive rocky bodies that formed farther from the sun and preserved water inside minerals. Unlike glittering comets with dramatic tails, these objects were darker, less romantic, and perhaps far more important. If enough of them struck the early Earth, they could have delivered tremendous quantities of water hidden inside stone. But then came the twist. Even asteroids might not tell the whole story. Deep inside Earth, in minerals dragged downward by tectonic forces or trapped during the planet's formation, scientists found evidence that the mantle itself may hold staggering amounts of water. Not liquid oceans, but water bound into crystal structures under immense pressure, locked into rock hundreds of kilometers below our feet. Some estimates suggest that Earth's interior may contain the equivalent of multiple surface oceans hidden in mineral form, invisible yet real, part of a vast deep reservoir cycling slowly through geological time. That changed everything. Because if water was stored inside Earth from very early on, then our planet may not have been born completely dry after all. Some water could have been incorporated during formation, absorbed into dust grains and minerals before Earth fully assembled. In this view, the building blocks of our world already carried the ingredients of oceans. Earth was not simply waiting for water to arrive. It may have been hiding water in its bones from the beginning. And yet survival remained the greater miracle. When a Mars-sized body struck the young Earth and helped create the moon, the energy released was beyond imagination. Entire layers of the planet may have melted. Any surface water present could have vanished into steam or been blasted into space. By all logic, this should have reset the planet, but perhaps not completely. Some water may have endured deep underground, shielded within molten rock, later escaping through volcanic outgassing. In that process, the Earth itself would have exhaled oceans into existence. Steam rising from countless eruptions, condensing as the planet cooled, falling as rain not for days or years, but for ages. Now the mystery grew larger. Earth's water was no longer just a gift from comets or asteroids. It was part cosmic inheritance, part planetary memory, part geologic resurrection. Delivered from space, hidden in minerals, cycled through fire, and released again through an atmosphere thick with volcanic breath. The oceans were not simply poured onto Earth. They were assembled, destroyed, buried, and reborn. Which means the real question is no longer where water came from. It is why Earth, unlike so many other worlds, became a planet able to hold that water long enough for life to begin. That question leads to the most astonishing truth of all. Water alone does not make a living planet. It can arrive, freeze, vanish, or burn away. Mars once had rivers, lakes, perhaps even seas, yet its surface became a cold desert. Venus may have possessed ancient water too, but whatever oceans it had were lost as the planet turned into a furnace hot enough to melt lead. In the solar system, water is not rare enough to be miraculous. The miracle is stability. The miracle is balance. The miracle is Earth. Our planet survived because it occupied a narrow line between catastrophe and emptiness. Far enough from the sun for liquid water to exist, but close enough to avoid becoming a frozen wasteland. Large enough to hold an atmosphere, but not so massive that it trapped heat like Venus. Violent enough to build continents and recycle minerals, but not so violent that every ocean was erased forever. Even the moon may have played a silent role, stabilizing Earth's tilt, moderating climate over immense spans of time, helping the planet remain predictable enough for water to persist and life to adapt. What looks ordinary to us may, in cosmic terms, be almost impossibly precise. And water did not simply sit on Earth like decoration. It became the engine of transformation. Rain attacked stone and drew carbon from the atmosphere. Oceans stored heat, softened climate, and became chemistry labs on a planetary scale. Deep beneath the seafloor, water entered rock, changed minerals, fueled tectonic movement, and helped shape the continents themselves. Every wave on every coast is connected to forces reaching into the mantle. Every storm is tied to a system billions of years in the making. Water is not merely something Earth has, it is something Earth does. Then comes the most intimate twist. The story of Earth's water is also the story of us. The hydrogen in your cells may have formed not on Earth, not even in the solar system, but in the first minutes after the universe was born. The oxygen you drink with every swallow was forged inside ancient stars that died before the sun existed. Those atoms wandered through interstellar clouds, entered the young solar system, survived collision and fire, became oceans, entered primitive microbes, passed through endless chains of life, and now move through your blood. In that sense, the water within us is older than mountains, older than Earth's crust, almost as old as time itself. But this epic origin carries a warning. We live as though water is permanent because, on human timescales, it seems endlessly renewed. Yet the history of planets says otherwise. Water can disappear from worlds. It can be locked away, poisoned, diverted, overheated, or lost. Earth's blue surface is not proof of inevitability. It is proof of fragility, protected by a rare planetary equilibrium. The same system that made life possible can be disrupted. Not easily on the scale of cosmic catastrophe, but enough to change civilizations, landscapes, and futures. Every reservoir, every glacier, every monsoon is part of a balance far older and more delicate than we once believed. So when we ask where Earth's water came from, we are asking more than a scientific question. We are asking why this world became a refuge instead of a ruin. Why blind cosmic violence produced blue oceans instead of sterile rock. Why atoms born in the chaos of the early universe gathered here, on this single world, and rose one day as thought, memory, and wonder. We measure history in kings, empires, and centuries, but the water that made us was traveling long before any nation had a name. It fell before there were trees. It flowed before there were animals. It waited in darkness before there were eyes to see the sea. And perhaps that is the deepest meaning of Earth's oceans. They are not just the background of human life. They are the ancient cosmic memory of everything that had to happen for us to be here at all.